Problem number 9, a rectangular piece of wood 50 mm by 100 mm in cross-section is used as a compression block shown in the figure. Determine the actual force P that can be safely applied to the block if the compressive stress in the wood is limited to 20 meganewton per square meter and the shearing stress parallel to the grain is limited to 5 meganewton per square meter. The grain makes an angle of 20 degrees with the horizontal as shown. Yung nakikita natin dito, ito yung mga to, ito yung grain na tinutukoy niya. And this force P here is perpendicular to the cross-sectional area wherein this 100 mm is the width, and kung i-visualize natin ay ito yung itsura niya. So this side here is 100 mm and this side is 50 mm, and this force P is acting here, and this is the grain. If we are asked to determine the actual force P that can be applied, kukunin natin yung dalawang components. Since naka-inclined yung grain ng wood, then we would have components of the force. Kakaroon tayo ng free body diagram. In this free body diagram, makikita natin dito that this is the force P, and this line here, kung makikita natin, this is the wood grain. The force P would have the components parallel to the grain, and this would be the shear force. And the components perpendicular or normal to the grain is the normal force. If the angle of the grain makes 20 degrees with the horizontal, so if this is 20 degrees with the horizontal, meaning this is also 20 degrees. So if we are going to compute based on the maximum compressive stress, we have to use the force N. So from the idea of the normal stress is equal to the normal force over the area, and we have the normal stress in this case. If this is N, this side here is also equal to N. So kung makikita natin dito, if this is P and this is N is adjacent side of 20 degrees, so meaning N is equal to P cosine of 20 degrees. Now for the area normal to the force, so ganito yung magiging scenario. We would have, this is 20 degrees here, and itong area na to, ito yung area na i-consider natin, yung naka-inclined. So magkakaroon tayo ng yung width, which is 100, and this is 50. So if this is 100, aalamin natin itong value ng diagonal. Since the area is equal to diagonal multiplied by 50. So kung titingnan natin dito, we have the adjacent and the hypotenuse. So we have cosine. So it's cosine of 20 is equal to adjacent side, which is 100 mm, over the hypotenuse D. So D is equal to 100 over cosine 20. So area is equal to D, which is 100 over cosine 20. So we have here 100 times 50 over cosine 20. Now if we are going to compute this, we would have 100 times 50 over cosine 20. And this is equal to 5320.89. So we have here 5320.89 mm square. So we have here the normal stress is equal to N, which is P cosine 20, but from here we have the compressive stress is limited to 20 meganewton per square meter, or that is 20 megapascal. So we have here 20, it's equal to N, which is P cosine 20, over the area, which is equal to 5320.89 square mm. So this 20 here is in megapascal and this is mm square. So yung lalabas na sagot natin for the P is in Newton. So computing for the value of P, we have 20 is equal to P, palitan natin ng X, cosine 20 over 5320.89, and shift solve equals, so we have 113,247.46 Newton. So P is equal to 113,247.46 Newton. So we have P is equal to, if we are going to express this in kilonewton, divide this by 1000, so we have 113.247 kilonewton. Now if we are going to base on the shearing stress, so we have the shearing stress is equal to the shear force over the area. So from here we have the shear force is opposite of 20 degrees and the hypotenuse is P, so we have that is sine, and we have V is equal to P sine of 20 degrees. Since the shear stress is limited to 5 megapascal, so we have here 5 is equal to the shear force, that's P sine 20, over the area, which is 5320.89 mm square. So solving for the value of P, we have 5 is equal to, si P palitan natin ng X, sine 20 over 5320.89, shift solve equals, and we have 77,786.21 Newton. So we have here 786.21 Newton. Now if we are going to express this in kilonewton, so we have P is equal to, divide by 1000, so that's 77.786 kilonewton. Since the question here is what is the safe value of P that can be applied, so we have two choices based on the compressive stress, that's 113.247 kilonewton, and based on the shearing stress we have 77.786 kilonewton. So we will go with the lowest value, and that would be the safe value, P, and the answer is this. So we have the safe value of P is equal to 77.786 kilonewton.